Welcome to this lesson focusing on Kubernetes services. We've gotten pretty good at deploying containers, but now it's time to start talking about how we access those containers. Kubernetes clusters will have pods starting, stopping, scaling, and we need a reliable way to discover and access these containers. Each time these containers are restarted, or new ones are added for scaling purposes, these pods get new IP addresses. So we need a way to access whichever containers are running and healthy. Kubernetes services do this for us. As new pods become healthy, the Kubernetes service identifies them and tracks their network addresses for us. In some ways, you can think about them as a load balancer that sits inside the Kubernetes cluster. In fact, it even has its own virtual IP address and port. And the port for the service can be different from the pods that are being tracked by it. Now, the way services discover how to access pods is by labels. Just like we used labels in the discussion with the replica sets earlier in the course, we'll use them again with services. Here I've labeled each pod with an app label called My App. I've also added a second label that might be used for a tier. And I've labeled two of these pods with a web tier label and a third with a database tier label. The Kubernetes service has a selector where you define which pods you want to track with the service. Here I've added a selector on the app label with a value of my app. In this situation, this Kubernetes service would forward traffic to one of the three pods shown here. However, we probably don't want to send web traffic to the database tier. So it might be better to add both labels to our selector in the service. In this case, we only want to match pods that have an app value of my app and a tier value of web. Let's take a look at what a Kubernetes manifest looks like. Another YAML file this time with a kind of service. And we of course have our metadata section to give it a name or add labels. One important section here is the selector section, which identifies what pods this service will be tracking. In this case, any pods that have labels app of app1 and a tier of web. Lower in the manifest, we see ports listed. The port field is the port of the service itself. As a client, you'll request info on this port. In this case, we're using port 8080 for the example. The target port identifies what ports the containers are exposing. The service will send traffic to the pods over this port, which is HTTP port 80 for our Nginx pods. Before we try this out in the terminal, let's show visually what we're about to do together. We'll deploy some Nginx pods, which are exposing port 80. We'll then deploy a service on port 8080 that matches the Nginx pod labels. Once those are deployed, we'll run a special test container to run a curl command against the Kubernetes service to return the Nginx welcome page. Just a quick note, you won't be able to access this Kubernetes service without using the curl container because the service is not exposed outside the Kubernetes cluster yet. You'll need to check out the next lesson to fix that. Okay, in the terminal, we'll start by deploying a manifest that has both a deployment of our Nginx pods and a service that matches those pod labels. After deploying the resources from the manifests, we can check on the pod status, which looks good. In much the same way we list pods, we can run a similar command for services. We can list the services by running kubectl get service, and I'm using the -o wide switch to get more details. We can see the port is 8080, and the label selectors for this service are shown as well at the end. Let's describe the service so we can see more information about it. We can see again the selector, the IP address, the target ports, and the endpoints. These endpoints correspond with the IP address and ports for our Nginx containers. In fact, these endpoints are something that you can query from the API server, and I'll split my terminal window here to show these endpoints, and I'll add the --watch switch so we can see them as they change. In the left terminal window, I'll list our pods so that we can see them and then delete one of those pods. Remember that these pods are part of a deployment and subsequently a replica set, so when we delete one of the pods, the controllers will replace them to meet our desired state, which is 3 in this case. As we do this, notice that the endpoints on the right adjust as the pod is destroyed and a new one takes its place. This is the service tracking the pods. Okay, so our service seems to be updating correctly. Let's test out if it actually provides us access to the pods. We'll run an imperative command to deploy a pod named curl pod, and we'll also exec into the pod to an interactive terminal. From that pod, we'll run curl with a destination of the Kubernetes service name, nginx service, and specify the port 8080. The result is that we return the simple nginx welcome page, but our test has worked. Thanks for following along in this lesson on Kubernetes service, and good luck in your labs as always.